stop button, and it'll go through a shutdown process and shut off.
So it won't just kick off. It'll go through a process as it shuts down.
Yeah, the compressors have to unload. You don't want them starting loaded up. That's really high amp draw. So these things are designed to unload 100%, and then they shut off. So it takes a few minutes for it to shut down. To start it, all you gotta do is press auto. It'll go through a startup process. There's time delays in between starts, so they can set for like 2 minutes. So it'll take, when you start it back up, it'll take 2, 3, 4 minutes before it actually does start a compressor.
Right.
And then the compressors will start and stop depending on like hot temperatures. So this is your control side. This side is all your high voltage stuff. You don't want anybody getting in these panels. This is all 480 volts. All of this is 480 right here, so you don't want anybody touching any of this stuff.
Right.
This is how you turn your pump on and off. So you turn that switch, it'll turn it off. This chiller does not have any flow proving on it now, so there's no flow switch. So it might be a good idea to maybe add that in the future, because you don't want this thing starting up with no flow, because you can freeze the chiller barrel up, the burst tubes, all that kind of stuff. So the flow switch is a basic safety item that's on every piece of equipment that's liquid cooled. Generally, it's installed in the piping system after a piece of equipment's put in place. So that's what these jumpers are right here. And I've jumped out the flow switch because you don't have one.
Okay.
So, and that's something that if you're gonna put a vent in that pipe next year, it would be a good idea to put like an 1.25 inch bushing in there, and then permanently install a flow switch, and you can get it wired up here. It's a good safety device to have, because if your pump shuts down, this thing has no way of knowing that.
Right.
And it'll continue to run the compressors, and it could actually freeze up and burst tubes, and then you're looking at a new chiller.
Okay.
So that's definitely something that'd be a good idea to add.
So if our pump shuts down for any reason, we need to shut this down.
Yeah, you've got to shut this off first. Yeah, stop this thing first.
Yeah.
So when they come to do the bearings and stuff, you want to stop this chiller first and then shut the pump off.
Okay.
So then,
and how do we do that?
So which you flip that to the left?
Just flip that switch and then that'll Yep. So this is
and that'll shut this down.
No.
That shuts the pump down.
Just
Okay.
the pump only,
Yep.
Yeah, so kind of crappy the way they installed this. This isn't really the way it should have been done, but that's what they installed for a switch on it. So this is a circuit breaker for the pump. So if you need to service the pump, turn that off, shut off that breaker, and then you can take the motor out and work on it and stuff like that.
Okay.
So this is your pump contactor. This is what starts and stops the pump.
So let me ask this real quick. If we had to shut it down, we first hit stop, and then we open it up and turn the pump off.
Correct.
Okay.
Yeah, and then when you start it back up, it's the reverse. You start the pump first.
Start the pump first.
Yeah, and then start the chiller up. So,
okay.
Yeah, you guys really should put a flow switch on this thing if you're going to keep it. So.
And if we were starting this, which we're not, we just hit auto or...
Yep,
okay.
just hit auto and it'll go through a startup sequence. So if you have any problems with this alarm light's going to be flashing on it.
Okay.
So we did get a low refrigerant pressure alarm earlier. I had to change all the settings on this. This machine was not designed for these temperatures. This machine was designed for comfort cooling, which is 40-degree water. So I had to change all of the safeties and the programming on it to make it run down to 15 degrees.
Okay.
So you may see a few alarms on here occasionally, low refrigerant or whatever. There's different types of alarms. There's non-latching and there's latching. So a non-latching will just, when the whatever caused the alarm clears, whatever fault clears, it'll automatically restart. If it has major faults, it'll actually lock out the circuit and it'll require a manual reset. So you'll have to go through the diagnostics menu and it'll tell you what to do to reset it. You basically, on the screen, it says hit enter to clear faults. So you'll just go through the screen and do that. So here's your interface system. So chiller report shows you all the status of the chiller. Hit next. It says you're running in local mode. Shows you both compressors are running. Nothing's locked out. This is your entering and leaving water temperature. So you just scroll through to get your data for that. You're running 59% of full load amps right now, so it's not even running 100%. Outdoor air temperature is 32. So then you can go to your refrigerant report. So this shows your low side, high side pressures for each circuit. That's your saturated refrigerant temperature. So you're running 0 degrees inside the refrigeration system right now. And this is all the stuff that you're going to log. You're going to go through and it'll show you circuit 1, circuit 2. You want to go through and log all the data for each circuit. You have the compressor report. So that tells you right now both compressors are running, nothing's locked out. That gives you your 103% of line voltage. Shows you which compressors are running, shows you the percentage that they're at. And then that shows there's your oil temperature there. We're 130 degrees on that circuit. And then as you keep scrolling through, there's your starts and hours. It's possible that these are fairly new compressors. If somebody actually reset all this and that's accurate, these only have 10,000 hours on it.
Right.
And they're really quiet, so it's possible that's all they have on. So these things, you can run 100,000 hours on a screw compressor. So if that's actually the case, you guys probably got a decent machine. So if that's accurate, that's the thing. So, and then that, if it keeps scrolling, it goes through your B side. So you got this is your A circuit, circuit 1, circuit 2 is your B circuit. So
Okay, so circuit 1 is A, circuit 2 is B circuits.
Yeah, they're listed as A and B in here.
Okay.
1 and 2. So you have your operator settings here. If you have to change your chilled water set point, that's right there. So you just press up and down and hit enter and it'll save it.
Okay.
So if you need to adjust that, you can.
Why would we need to, or is that something?
Probably not.
Yeah, tell us what you told us yesterday
Yeah,
about the set points.
So these things, they're only designed for a certain amount of tonnage. So turning your glycol temperature down to 0 degrees does not get you any more refrigeration. So don't let people come over here and, we got water on the ice, turn it down, it'll freeze. That's not the way it works. So you're dependent on outdoor temperature, sun loading, and just the capacity of this chiller, whatever that is. So turning down to 0 is not going to get you anything better. So in fact, it'll actually cause this machine to lock out because your refrigerant pressures are going to run lower, and then it's going to start locking out on safeties.
Okay.
So it's going to try to protect itself.
And so we're set at 15 degrees.
So that's 15 degree return. So the leaving temperature is going to be lower. You're probably seeing 9 or 10 degrees on your leaving temperature.
Okay.
So yeah, if you set that, if you set this down to 10 degrees, it's going to be leaving at like 0.
Okay.
And then you're going to be bumping up against your safeties. So
yes.
because this has low pressure, low temperature safeties in it. So as it's monitoring all this stuff, it's trying to protect itself is what it's doing. It's trying to keep from freezing the barrel up and destroying the chiller.
Okay.
So that's what those safeties are meant for in here.
So our set point is our return
from the floor.
Return from the floor.
Yeah.
Okay.
So
Gotcha.
if you need to change that, that's where it's at. You probably won't. I mean, you might decide, hey, we need to harden the ice up a little bit or whatever.
That's what I was gonna say. How will we know?
I mean, with outdoor rinks, there's not. I mean, you can't really do that.
Yeah, I've been through that a bit, so we'll know
the
that.
difference for hockey and figure skating, the different set points they like, and outdoors you really can't do that.
Yeah.
So indoor, you can harden the ice up a little bit by turning it down, make it a little bit softer, for the different skating. But.
Well, with the indoor rink that I was running, when we put the ice in, we're flooding and putting in stuff, we turn it down to I think 13 or 12 degrees, maybe 10. But then we normally keep it about 17, 18. Actually, 20, 21 is where
you could do that here if you wanted to, if you wanted to lower.
And it would help a little bit with the speed of it, but other than that, so
if you wanted to turn it down to like 12, I don't think I'd go much lower than that because we're going to start blocking out on safeties. Since this thing is running, I'm going to leave all the safeties where I set them. If I come in today and it was locked out on something, then I'd probably lower them a little bit more. We did not test your glycol percentage. We're